Hello, my name is Molly O'Connor, and this is my review of microbiota transfer therapy and the potential long-term benefits on autism symptoms and gut microbiota. It's a review of an open-label trial of microbiota transfer therapy and post-treatment, 2-year follow-up trial. Environmental and genetic factors both contribute to the etiology of autism spectrum disorders. The gut microbiome is a key environmental factor that may influence ASD symptoms, and an increasing number of studies have found that children with ASD have unique gut microbiomes compared to their neurotypical peers. Individuals with ASD, Parkinson's, and Alzheimer's disease often share chronic gastrointestinal GI symptoms, indicating the presence of a gut-brain axis. Pardon me. There is a strong correlation or association between ASD and GI disorders with high comorbidity and evidence of a correlation between ASD symptom severity and severity of GI symptoms. In microbiome analysis, several studies have observed relatively low representation of members of Prevotella and other fermenting microbes compared with typically developing children. A recent small pilot study by King et al. And follow-up, which I reviewed, indicated promising results for fecal microbiota transfer therapy, FMT therapy, in the treatment of ASD. Preclinical studies have also highlighted the vital role of microbiota in various mouse models of autism, such as maternal immune activation, maternal high-fat diet, as well as in specific ASD symptoms like repetitive behaviors. Although these studies provide correlation, not causation, the case for microbiome-based treatment for autism spectrum disorder symptoms is growing stronger. Effective autism spectrum disorder treatments may include behavioral, speech, and social therapies, as well as dietary and medical approaches. However, no medical treatment has been approved for core symptoms like social communication difficulties and repetitive behaviors. Several pathways of interaction between the gut and brain have been identified, including via the synthesis of metabolites and neurotransmitters, vagus nerve activation, and immune system activation. Given the gut-brain connection, altering the gut microbiome through antibiotics, probiotics, prebiotics, and or fecal microbiota transplant therapy may be a viable therapeutic option. In FMT, a healthy donor's diverse and abundant commensal microbes are used to restore a dysbiotic gut microbiome to a healthy state. The GI tract hosts the largest population of microorganisms in the human body, with over 60 genera of microbes and more cells than the human body itself. Research increasingly has connected the microbiome to psychological processes and neuropsychiatric disorders that include mood and anxiety disorders, autism spectrum disorder, schizophrenia, and neurodegenerative diseases like Alzheimer's and Parkinson's. Most psychotropic medications are likely to impact the microbiome. The methods for the first phase of this trial was an original study that was an open label modified FMT clinical trial. 18 children aged 7 to 17 years with autism spectrum disorder and moderate to severe GI problems were enrolled in the original study. Medical histories of the participants were reviewed to exclude children with known GI diagnoses like Crohn's disease, celiac disease, eosinophilic gastritis, or similar conditions. Then an intensive combination of MTT, microbial transfer therapy, was included. It's microbiotic transfer therapy. Involved a 2-week vancomycin treatment to reduce pathogenic bacteria, followed by a bowel cleanse to remove vancomycin and the remaining bacteria. Then Prilosec was introduced in high maintenance doses of standardized human gut microbiota, that is the gut bacteria from healthy donors, SHGM, were administered. A high dose of FMT for 1 to 2 days, and then 7 to 8 weeks of daily maintenance doses were combined with stomach acid suppressant Prilosec. The participants were then monitored during the 10 weeks of treatment and again 8 weeks post-treatment. No major adverse effects were reported, and all 18 participants completed the study. Most children had substantial reduction of their GI and ASD symptoms. Improvements post-intervention remained at the 8-week follow-up observation. After the 10-week MTT treatment and 8-week follow-up observation period, which was 18 weeks in total, 80% experienced reduction in their GI symptoms, and there was a slow but steady improvement in core ASD symptoms of the participants, which were observed by the researchers. The gut microbial diversity significantly increased in the participants after MTT, and 2 years post-original clinical trial, the participants were reevaluated to determine whether observed some improvements in behavior and the GI symptoms persisted. The long-term impact of MTT on the gut microbiome of the study participants was then evaluated at 2 years post-phase 1. And that is what I reviewed. The follow-up involved the same children with ASD, the same 18 participants, which is great that they all remained. And it was also used to determine the long-term safety and efficacy of MTT. It was mixed methods, assessments of the GI and ASD-related symptoms. Researchers evaluated GI symptoms using a revised version of GI symptom rating scale, GSRS, for consistency, which uses a 7-point Likert scale on 5 domains: abdominal pain, reflux, indigestion, diarrhea, and constipation. They recorded daily stool samples using the Bristol Stool Form Scale, 1 equaling very hard, 7 equaling liquid, for over 14 days. For the autism spectrum disorder and related symptoms, the same assessments from the phase 1, the first phase, were used and included the Parent Global Impressions 3, PGI 3, the Childhood Autism Rating Scale, CARS, the Social Responsiveness Scale, SRS, and the Vineland Adaptive Behavior Scale 2, the VABS 2. The CARS evaluation was conducted by the same evaluator as the original study, and the parents assessed the GSRS, the DSR, the PGI-3, the ABC, and the SRS and VABS-2 at approximately 2 years after the therapy stopped. The informatics that were used were the 16S ribosomal RNA gene data from the previous sequencing run was generated from the 4 Illumina mini sequence runs, and the follow-up data, which was new to the study, the complete study, was sequenced on a single mini sequence run. Analysis were performed on the forward reads only to retain as many sequences as possible, to ensure consistent processing across all of the runs, and to enable the use of the most recent bioinformatics methods for microbiome analysis. All 5 of these sequencing runs were processed together in a single QIIME2 analysis. Sequence quality control was performed with 2 different processing pipelines, both implemented in QIIME2. The QIIME2 plugins exist for the latest generation tools for sequence quality control from different sequencing platforms like Python, taxonomy assignment, and phylogenetic insertion, which quantitatively improve the results over QIIME1 and other tools. Sounds like an advertisement for QIIME2, but it does sound really cool. The plugin architecture also supports qualitatively new functionality, including microbiome paired sample and time series analysis, which are central for studying the effects of treatment and aiding in reproducibility, transparency, and clarity of analysis. Here is some data visualization from the study, which has the baseline and the 2-year analysis. And I think post first phase, 8 weeks. 2 years after the study, 18 original participants in the treatment group were invited back for follow-up. I think we covered that, but the same GI and behavior tests were performed. Improvements in GI and autism spectrum symptoms remained 2 years after MTT ceased. Most participants reported GI symptoms remained improved compared to baseline after the 2-year post-trial. On average, 58% of the participants experienced reduction and recorded it on their gastrointestinal symptom rating scale, and 26% had reduction in the percentage of days of abnormal stools. Families generally reported that the autism-related symptoms had slowly, steadily improved since week 18 of the phase 1 trial. And based on CARS, which were rated by the professional evaluator, the severity of ASD at the 2-year follow-up was 47% lower than the baseline, compared to 23% lower at the end of week 10. That's some improvement. At the beginning of phase 1, 83% of the participants rated in the severe autism spectrum disorder diagnosis per the CARS. At the 2-year follow-up, only 70% were rated as severe. 39% were in mild to moderate range, and 44% of the participants were below the diagnostic cutoff for autism spectrum disorder score. Overall, the most substantial improvements were on the CARS assessments. Because CARS is considered to be a stable and consistent diagnostic tool with high predictive validity, used to evaluate participants before and after therapeutic interventions in multiple studies. When conducted by a professional evaluator, the tool is less susceptible for a placebo effect. For the follow-up CARS, the evaluator collected current information based on each question's unique criteria. And after the interview was complete for each question, the evaluator reviewed the information initially collected at baseline and used it for calibrating the final evaluation. The statistical analyses were performed to assess whether improvements in GI and autism spectrum disorder severity were correlated, and the percentage of changes in CARS, SRS, and ABC scores were positively correlated, implying that the GI relief provided by MTT may ameliorate behavioral severity in children with autism spectrum disorder or vice versa. The DSR didn't show any significant correlation. Direction of influence was unclear. 2 years post-MTT, the participants with autism spectrum disorder showed increased fecal bacterial diversity measured by Faith's phylogenetic diversity and the observed operational taxonomic units, the OTUs. Taxonomic. Most participants maintained higher gut microbiota diversity 2 years post-treatment compared to baseline. Findings indicated that recipients did not fully retain the donated microbiome, but kept certain features of increased overall diversity and higher levels of important microbes like Prevotella, while achieving a new state of their own microbiome. At week 10, median relative abundances of bifidobacteria, and Prevotella increased by 4-fold and 712-fold respectively, and by 5-fold and 84-fold at 2-year mark. The increase in Prevotella after MTT is significant, as its lower abundance is usually found in the feces of children with autism compared to neurotypical children, and has been confirmed in 2 separate cohort studies. And recent studies have also found reduced levels of Prevotella in the oral microbiome of children with autism spectrum disorders. Long-term follow-up studies are rare for medical treatment of individuals with autism spectrum disorders or disorder, and further multi-omic approaches and studies are needed to clarify the role of Prevotella, the gut-brain axis, and the microbiome in the context and relationship to autism spectrum disorders. Long-term follow-up studies on medical treatments for individuals with ESD are rare. However, the gut microbiota transformation driven by MTT and the long-term benefits observed in this study are encouraging and suggest promising potential for lasting autism spectrum disorder treatment. Limitations and confounding factors of the study are that 12 out of 18 of the participants made 1 or more changes to their medications, nutritional supplements, and diets between the end of the original MTT trial and the 2-year follow-up since the treatment stopped. The original clinical trial and the follow-up study were open label trials without a control for placebo effects or the confounding factors, and the small size of the treatment group is also a limitation. Follow-up studies are needed to better understand whether the improvements by MTT were solely from the vancomycin, movie prep, Prilosec, standardized human gut microbiota, or a combination of the factors and in which way, how they relate to each other. Researchers hypothesis that MTT may also benefit children with autism spectrum disorder who do not exhibit obvious GI symptoms, but have low gut bacterial diversity, as previous studies have found associations between low bacterial gut diversity in children. There's a relationship between children with autism and low gut bacterial diversity. Low bacterial gut diversity. MTT is a promising therapy for treating children with autism who have GI problems. There's a need for subsequent follow-up studies that include a more thorough examination of participants' GI pathologies to better understand the efficacy of MTT. Ultimately, observations from the follow-up study were encouraging, showing significant improvements in both GI and behavior symptoms compared to baseline measurements. And the GI benefits observed in participants at the end of phase 1 were mostly maintained 2 years after the follow-up. 2 years after from the recordings or the assessments made from the follow-up study. Autism symptoms were reported to have improved significantly since the end of treatment. Changes in gut microbiota of participants persisted at 2 years, including overall community diversity and relative abundances of bifidobacteria and Prevotella. Future research is needed that includes larger cohort size, study design that incorporates double-blind, placebo-controlled randomized trials. Here are my references for the analysis and presentation, and thank you guys so much. Have a great rest of your day.